Okay. So, so over the last classes, what we were doing is we have been trying to go through these testing models, right? So we have completed the tests for statistical hypothesis. So we have actually completed the entire framework of modeling. The entire framework containing the statistical inference. So there were three broad topics: the theory of sampling, the theory of estimation, and the theory of uh, estimation and testing. Okay. So over here, in the last session, what we were talking about is we were talking about the different kind of tests which were there. So we talked about the single mean test, the mean difference test, and with the mean difference test, we were talking about the t-test. Now with t-test, what we talked about was that with mean difference test, we talked about the two independent sample t-test. So basically, the idea was that if I have two groups of observations, if I have two groups of two values, then, or if if I have two groups of values, then what I would like to understand is what is the difference in their mean. Say for example, so in the domain of credit risk modeling, right? So what I have done is I've created two segments, segment A and I have created segment B. Now with segment A and segment B in place,
Okay, okay.
what I want to do is I want to understand whether these two are stable segments or not. Now for doing that, what I want to know is that one basic characteristic for a segment to be stable should be that you know that its bad rate must vary significantly across the two groups. So if I have to do this, if I have to identify one segment as a high risk segment and another segment as a low risk segment, then what we would love to do is we would love to know whether there exists a significant difference in the average bad rates across the two segments. And that is where the role of the mean difference test comes in. And our idea over there is to know whether the mu1 minus mu2 is equal to 0 versus the alternate hypothesis mu1 minus mu2 not equal to 0. So these are the two important things that we are going to that is these are the two important that we are going to consider, right? So the one is the null hypothesis and the other is the alternate hypothesis, right? So over here in this way, what we would like to understand is the following: that how do we do the test? So that test is done using the t-test statistic, the value minus mean divided by the standard error. Now once we have this, once this particular part is done, the next part that we would like to know is that how do I take the decision rule? So the decision rule is taken by comparing the p-value and the alpha, which is p-value and the level of significance. So if the probability of committing the type 1, if the actual probability of committing the type 1 error is less than the than the maximum acceptable error, that is the level of significance, then we say that yes, there is a significant difference in the mean. So this is one of the cases that we had explored in the last class. So one basic conclusion that we can derive, from the discussion that we had till yesterday, was that the mean difference test finds a very important application. So mean difference test So the mean difference test finds very important application in assessing the segments, is important in assessing segments. In assessing segments, right? So over here, this is what precisely is the idea. Now, the next part that we need to do is, the next part that we need to work around is what are the actual business cases. So let's try and explore some cases where we may use this particular characteristic of or this particular test in exploring or in assessing the stability of the segments. So let's take one example of origination for a personal loan. Origination for personal loans. Okay. So the first question that comes out is that we have been talking about segments, right? We have already discussed segments. So what exactly is segmentation? Or what exactly are segments? Ideally, segments are homogeneous groups of loans. Segments are homogeneous groups of loans. Are homogeneous groups of loans. Homogeneous segments are homogeneous groups of loans. So these are loans, where we get to see the following. That where we get to see that so these are groups of loans where uh, how should I put it? So these are groups of loans which are homogeneous in nature. So how do we define homogeneity? So homogeneity is defined in terms of riskiness. So basically, what we are saying is the loans in a segment, right, are similar in terms of their riskiness. Similar in riskiness. Riskiness. Similar in riskiness. So basically, how do I identify similar in riskiness? So it means that, say for example, if I talk about two segments, A and B, and I say that a segment A is less risky than segment B, then the first and the most important thing that comes to play over here is that the average bad rate of segment A has to be less than equal to the average bad rate of segment B, right? So this is something that we need to understand. Okay. Now, having said this, the next part that we need to talk about over here is that uh, how do we discuss or how do we define these bad rates and stuff? So, what should be our logic for defining these bad rates? Over here, let's take this into consideration. That, say for example, there is a segment A, and I say that segment A is less risky than segment B. So that means the average bad rate of segment A is lower than the average bad rate is R1 and this is R2. Now obviously R1 is less than R2. Right. So this is what is basically the idea of the bad rates. Or this is what is the difference. I mean this is what is the difference in the the overall bad so this is what is meant by that the average bad rate in segment A must be less than segment 2. That is, segment A contains the homogeneous groups of accounts which are similar in terms of the riskiness, and segment B contains the same kind of a similar kind of account which are relatively more risky than segment B. Now there are different ways of performing this segmentation exercise, right? So as we go ahead, we will be talking about, so as we talk about chi-square distributions, as we talk about the other frames of distribution, we will be coming to that. So we'll be talking about decision trees and all, so we will be coming to that particular part. But over here, let's first understand that how can I implement the mean difference tests to do this segmentation. Now ideally, mean difference tests cannot be implemented to do a segmentation. So a segmentation is done using a decision tree. Right. So segmentation is done using a decision tree. And the segments are generated. So the segmentation criteria is identified, and using that segmentation criteria, right, the decision trees are generated. So using decision tree, the segmentation criteria is determined. The segmentation criteria is determined, and based on those, segments are created. Now comes the next part. And when the segmentation criteria is generated, right, when the segmentation criteria is created, the next part that we need to understand is the following: that whether the segments created are stable segments or not. And to assess the stability, right, we need to ensure that there is, first of all, a significant difference in the mean, and that significant difference continues over any given period of time. So if I give you a segment A which is less risky than segment B, the bad rates in segment A should always lie below that of segment B. So this is what the overall idea is. So let's consider the case for personal loans. About personal loans, one very important segmentation criteria which I have seen is the overdraft versus the non-overdraft segments. Right. So it was the overdraft versus the non-overdraft segments. So over here, when I look into the overdraft, now the first question that comes out over here is that why is it that we are considering these two as two separate segments? So what is the business idea behind this? So obviously what I have is the OD segment over here, and next what I have is the non-OD segment over here. The non-OD segment. Right. So over here what we have is OD, and the next what we have is the non-OD. So first of all, let's consider the case that why are we looking into an OD versus non-OD segment. So over here, say basically, there are two borrowers who come up to me. Say there is a borrower A and there is a borrower B. These are the two borrowers who are there or who come up to me. Right? Now I see that, and both of them come asking to me for a loan. Both of them come up to me asking for a loan. Right? So the next case is, in the next case, what I get to see is that over here what I have is A and B, right? And over here what we have is personal. Now let us assume that uh, both these two borrowers are characteristically very similar to each other, right? So they are exactly the same except for the fact that this guy A has a overdraft and B does not have an overdraft. So this is the only difference between the two borrowers. Now think about a manager who is trying to manage risks. Now think about a manager who is trying to manage the risks of the borrower. So both of them apply for the loan. Now the manager sees that okay, both of them are exactly the same. So by the application scorecard, both of them are giving the same scores, and ideally both should be given. So what the manager tries to explore is this OD versus the non-OD. Now he thinks it in this way. Say there is a borrower A, and A has an overdraft limit of 2 lakhs. Right? Now, so A has a OD of this. Or let's forget that. Let's say this has an overdraft account of 20,000. And A has applied for a personal loan of 1 lakh. Right. Now A has a personal loan of 1 lakh. Now when A has a personal loan of 1 lakh, out of so he's taking the loan for 2 years. Now after the 1 year, so after 1 year, he has, like, you know paid back, like, say, let's say 60,000, right? And then he loses his job, so his credit rating or his credit standard goes up, deteriorations. There happens a deterioration in his behavior. Happens a deterioration, right? Now, after this deterioration has happened, right, what he can do is he could arrange for, like, say, he said that, okay, after a point of time, by after selling all my stuffs or after doing this, I could arrange for 25,000 more. Now, the amount that he has arranged over here is, so the total amount that he could pay off, or even after, after going in deterioration, he tried curing back, and he paid back a total sum of 85,000, including interest, right? Now, he still had some amount, he still had 15,000 to pay back, right? So there was a shortfall of 15,000, right? So there was a shortfall of 15,000. Now, if there was a shortfall of 15,000, so this guy could have, what the guy could do over here in this case is, he might use his overdraft, right? Draw back the 15,000 and pay back the 1 lakh. So the moment he does this, the moment he does this, right? The moment he does this, what happens is the following. The moment he does this, uh, he just, he just gets back the entire thing. So you just give him, so he pays back 1 lakh. But he has overdrawn from his account worth 15,000. So his current account or his overdraft is, or his account overdrawn by 15,000. Now, given that this account is drawn by 15,000, the exposure on the overdraft account is much more for the bank, because the rate of interest charged on the overdraft is much higher than on this personal loan. So, in order to get that personal loan out, what this guy could do is he could draw money from the overdraft and plug it in the personal loan, and thereby he might prevent himself from going delinquent or defaulting on the personal loan. But at the same time, what he would do is he would go he would default on the overdraft, or he might go delinquent on the overdraft, which creates a greater exposure of risk for the bank. Right? So one exposure might be mitigated, but the this exposure would get mitigated by drawing funds from the other account. And that is where the entire challenge would arise. Right? Okay, so is this part clear? That why is it that accounts with, say, why is it that accounts with overdraft is a relatively more riskier account? Great. Now, apart from this, the next thing that we need to know is the following: that so the next thing that we would need to know over here is that why is it that, or how is it that this particular account, right? So how is it that no, an account with an overdraft, how does riskiness differ across the accounts with the overdraft? Now, for example, let's take the case where a borrower has an overdraft. So this is my OD base. So this is a base of accounts which contains overdrafts. So within the OD base, there can be two kinds of sub risk classifications. One is accounts which have a positive balance or overdraft balance which is greater than zero. So it means that in the balance you have a positive bank balance which you maintain in that account. Right? And over here what you have is an OD which is less than zero. OD which is less than zero. So this is an overdrawn current account. This is overdrawn overdraft. So this is a case where your OD account is overdrawn. Now borrowers who has been historically been overdrawn. So these borrowers are borrowers who has, you know, kind of who has been kind of overdrawn, right? So over here, while I talk about this overdrawn current account, right? So when I say that a current account has been overdrawn, so what I mean by this is that uh, the OD balance is negative or the balance account balance. If I talk about the balance variable, the balance value is negative. Now these accounts are historically overdrawn. So this means that the borrower who is taking the personal loan, right, already has or has historically shown to have overdrawn OD balances or overdrawn current accounts. Now, if there are overdrawn current accounts, and this guy historically has, to have overdrawn his current account and all, then there are two sources, the two indication that goes out to the bankers. First is this guy has a tendency to take credit and not return back. The second is he has a tendency to overdraw his current account. So from the first tendency to take credit and not return back, the people might feel that okay, this guy who has taken the personal loan, right? So who has taken the personal loan is a person who may take the loan and may not give me back the money. In the second case, what we might see over here is that okay, even in case the guy goes into a default and becomes delinquent on the personal loan, he might just overdraw his account and try to pay that back. So in all respects of the term, in all respects, right, this is a very risky segment. This is a very risky segment. This is a very risky segment. Right. Because I know that this borrower is overdrawn and therefore he has every chances, number one, of taking the PL and not returning it back, and number two, he might actually take the loan. And so basically he might take the loan and not return it back. And number two is he might take the loan, and in case he defaults on the loan, to prevent that default, he might overdraw his current account and then just default on the OD balance. So therefore, this is a very risky borrower from lending. Now comes the second group. So over here, what I see is that there is a borrower who takes who has an OD balance, right? But he maintains a positive overdraft balance. Now, given that he maintains a positive overdraft balance, right? So he is a relatively less risky borrower. So this is a relatively less risky borrower. And borrowers who do not have overdraft, right, are always considered to be relatively less risky than the OD base. So they are the least risky borrowers. Given that all other acquisition details, acquisition factors remain unchanged across the classes, right? So this is what the overall factors are. Now, let us concentrate between these two borrowers, the overdraft balance and the non-overdraft balance. That means what I'm saying is that the borrowers who have an overdraft balance are relatively more risky than those without the non-overdraft, given everything else remains unchanged. Right? So therefore, what we need to do over here is the following. We need to check whether this segmentation structure is a stable segment or not. Is a stable segment or not. So to identify the stable segment, the first check that I need to do over here is that the bad rates should be significantly different. So the bad rates in segment 1 and the bad rates in segment 2 must be statistically significantly different. Statistically different. Right. So this is where the first check, and then to ensure that this check holds good, to ensure that this holds good, we incorporate the mean difference test. the mean difference test. So this is what, and this is where the mean difference test becomes important, right? This is where we use the mean difference test. Also, one another important thing that we need to ensure over here is that this segment, these two segments maintain the rank ordering. That is, over time, if I am plotting the bad rates, right? So at each point of time, this segment should show. So this segment should show that the borrower is. So this segment should always give a higher bad rate compared to the others. So basically, if I do a plot like this, so over here what we have is 9, and this is where it is the bad rates. Say for segment 1, which is the OD segment, so this is over time, this is the bad rate. This is for the OD segment. And over here, the non-OD segment. So over time, at each point of time, if you just take it up, it should always be the OD versus the non-OD. The non-OD segment's bad rate should always lie below that of the OD. This criteria a is called the rank ordering criteria. That it should always lie strictly below. So if it's a risky segment, then at each point of time it always is a risky segment. It must not be that at some point of time it is risky and some point of time they become very similar segments. So that should not be the case, right? So it should be the case that it should happen, or this riskiness should be the same, or the relative ranking of the riskiness must be the same throughout each given time point. Clear? Great. So over here, so this is one case where we use the mean difference test. Now the next question that comes out is that what if instead of the two segments I had the three segments? So in that case, t-tests cannot be used. And so in such a case, t-test cannot be used. And we introduce the concept of ANOVA, or the analysis of variance. Okay, so t-test that we have seen as a mean difference test is applicable only up to two groups of observation. T-test, two groups of observations. Of observations. So if I am trying to do, a kind of a t-test, right? So if I'm trying to assess the mean difference test for two or more, two groups of observation or up to two groups of observation, then t-test is all right. But after that, if I'm trying to do for three groups of three segments, right? So suppose I have created three segments in my model. Say I'm trying to develop a behavior scorecard for credit cards, right? I'm trying to develop a behavior scorecard for credit cards. And what I see is that there are three segments. Say a delinquent segment, then the second one is an active segment, or say non-delinquent segment. And the third that we have over here is an inactive segment. So now I have three groups of observations, right? Now if I have three groups of observations, the question is how do I do the mean difference test? And that is where the concept of that is where the concept of relative ranking or stuff comes in. So delinquent segment, non-delinquent, inactive, and if I need to identify the relative riskiness, if I want to create and to check whether these segments are like stable segments or not, what I have to do is I will have to check for the statistic, for the statistical significance in the difference in the bad rates, and that is where just give me a second. So over here, what we have is these two segments, right? So if I want to assess the difference in the mean of the two groups, what we have over here is the method that we use to test for the significant difference in the mean is ANOVA, or as we call it, the analysis of variance. So in ANOVA, what we do is we do the difference. So ANOVA over here is the analysis of variance. And in this particular method, what we do is we would like to analyze the variation across the groups, and based on that, we would try to frame our understanding of the differences in the mean. Right. So, how does that actually work? So, let's suppose that there are three groups. Say there is group A, there is group B, there is group C. So over here, say the observations over here are x11, x12, like this, x1n, x21, x22, x28. So similarly, what we have over here is x31, 32, x3. Now, how do I analyze the variance and reach to the mean? This is something which is very interesting. So, if you have a very quick look into this, it's a very intuitive fact. Now, if there is a significant difference in the mean between these three groups, then what we see is that the variation will rapidly change as you move across the groups. So as you move from group A to group B to group C, right, you'll see that the variations change rapidly about the mean. But over here, within the groups, while you move, if they are so homogeneous, then you'll see that as you move up within the group, the variations would not be changing very rapidly, because within the group the observations are more or less homogeneous, and across the group the observations are very heterogeneous in nature. Right? So, therefore, one way to identify the mean is that there would be a significant variation, right? So, there would be a significant variation across the group, and there would be very less or insignificant variations within the group. So, if there is very less variation within the group, then what we can clearly conclude over here is that the observations within the group are more or less homogeneous. And as we move across the group, when we see that the variation changes distinctly, then we can clearly conclude is that the value over there is, or that variation over there is more or less is very significant. So if there is insignificant variation within the group, it means that the observations are more or less similar, and that not much of a variation is recorded about the group mean. But across the group, if the overall variations deviate, I mean, if there is a very high deviation across the groups, then we can say that as I move from group A to group B, the overall behavior of the variable changes, and as I move from B to C, the behavior again changes. So therefore, a very distinct or a very prominent variation within the group variation, I mean across the group variation, and an insignificant within the group variation will tell us that yes, the averages of the variables change as you move from one point to another point. So from one group to another group. And then we can conclude that the mean across the groups are very different. So this is the way we use, or this is the logic using which we try to understand, we try to analyze the use of these statistical measures, right? So is the logic of the ANOVA clear? That what we do is we compare the across the group variation and within the group variation. Now, if the within the group variation is not very significant, it means that within the group the observations are more or less homogeneous. But when you move across the groups, if the variations changes very significantly, then it means that yes, there is a sudden or distinct change in the behavior as I move from A to B and consequently from B to C. Right? So this is where the role of variations actually come in. And ANOVA is used for multiple to test the mean difference across multiple groups. ANOVA is the method. And the use of ANOVA is extensively found in the linear regression models. Right? So in tomorrow's discussion, we'll talk about ANOVA, the ANOVA testing. For ANOVA, we need to develop the concept of an F test. We need to talk about the concept of a degree of freedom. And from there, the next thing that we need to talk about is its application to the linear regression models. Right? So tomorrow we'll complete that part. So tomorrow is what day? Thursday, right? So tomorrow we'll complete this part. With this, the basic statistical testing portions will be done. On Saturdays and Sundays, we'll start talking about. Friday there would not be a session. On Saturdays and Sundays, we'll start talking about the concepts of scorecard development and the SAS software. Right? So that's the plan going forward. Now, if there are other areas I feel that needs to be discussed, right? Some more of segmentation and all, and decision trees and all. So we'll do that on Saturdays and Sundays, or we start off with scorecard developments.
Tanmay, and also can you share those 4-5 days recording so I'll go through it?
Okay, I'll do that. Actually, I'm not
Okay.
getting the time,
Thank
so
you.
just let me send it on. I'll do that today.
Okay.
Yeah.
Thank you.
Thank you.
Bye bye.
Bye bye.